Leo Morales arrived at Helios Tech's seaside research facility just before dawn, clutching his battered wave energy converter prototype like a lifeline. The complex, perched on concrete pilings over the surf, was a hive of activity. Engineers in neon safety vests strode between labs. Technicians calibrated sensors on floating buoys, and the brine scent of morning salt mingled with the hum of diesel. Generators. Leo stepped around a stack of steel pallets toward Dock 3, sweat beading on his brow despite the cool ocean breeze. At Dock 3, he found his contraption, once the pride of his graduate research, half submerged and wedged in a tangle of discarded metal frames. Its aluminum blades, designed to flex with the waves, were bent inward. The starter housing, which contained his custom-wound copper coils, was corroded by saltwater leaks. Beside it lay his leather notebook, waterlogged and smeared, pages torn where he had sketched the final control circuit diagrams. A bright yellow dump sticker fluttered on its side, slapped there by a newly appointed project manager who had deemed Leo's design too risky. Leo's heart pounded as he knelt in the wet sand mixed with oil slicks from passing workboats. He pried off the sticker, the adhesive peeling a patch of marine paint. He lifted the prototype's main support arm, its stainless steel welds pitted but still solid, feeling the familiar heft of the generator's rotor shaft. Memories flooded back. Late nights soldering thermocouple sensors, countless iterations of the blade curvature to maximize torque, and the triumphant whir when he first recorded 5 watts per wave cycle in the sheltered bay of his coastal lab. A shout rang out. "What are you doing, Morales?" Leo turned to see Jasmine Ford, the project manager, striding up with 2 security attendants. Her crisp Helios Tech badge gleamed under the floodlights. "You're not authorized to retrieve discarded equipment. That prototype is company property and a liability," she snapped, tone sharp as a breaking wave. Leo rose, dripping salty water, voice steady despite the adrenaline. "That prototype is my life's work. You can't just throw it away." He brushed the mud from his jeans. "Give it back to me." Ford's lips curved in a patronizing smile. "Your contract here was terminated last week. Your IP assignments transferred to the company. Now step away, or I'll have security escort you off the premises." Leo's chest tightened. He glanced at his ruined notebook pages, the torn circuit diagrams, then back at Ford's unyielding posture. He knew the security guards meant business. With a final glance at the smashed converter, he spun and walked away, each footstep splashing through puddles of oil and salt water, swearing under his breath that this would not be the end of his invention. Even if Helios Tech had discarded his prototype like refuse, Leo vowed he would resurrect it and prove that the power of the waves could not be so easily silenced. That evening, Leo hauled the soaked fragments of his wave energy converter to his uncle's sailboat workshop at the edge of town. The workshop was a cavernous space of teak planks, canvas sails, and coils of rope, its air tinged with varnish and brine. Overhead, a single flickering lantern cast long shadows across workbenches littered with marine tools, block and tackle assemblies, bronze fittings, and a lathe once used to turn custom mast hardware. Leo set the battered turbine blades, salt-crusted and misshapen, onto a heavy oak table beside a stack of polished wood spars. First, he tackled the aluminum blades. He clamped each one into the workshop's bench vise, taking care not to crush the thin flanges, and gently straightened the bends with a soft face mallet, tapping along the length until the curved airfoil profile was restored. He then applied a fresh coat of marine-grade epoxy resin and grit, his own formula, to the leading edges, sealing hairline cracks and restoring structural integrity. Next, he retrieved rolls of high-tensile stainless steel cable from a coat rack of rigging lines and fashioned new tensioning straps to keep the blades aligned under wave loads. Turning to the generator housing, Leo drained and discarded the corroded lubricant, then flushed the stator compartment with fresh deionized water. He removed the outer casing, its clamps warped, from the water intrusion seals and slid out the starter assembly. Using his uncle's jeweler's loop, he inspected the copper windings, several turns disrupted by salt-etched insulation. With precision tweezers, he unwound the damaged sections and rewound fresh, varnish-insulated copper wire, using a small drill as his makeshift winding lathe. He layered each coil with protective varnish, and baked it gently over a low heat lamp borrowed from the navigation station to drive out moisture. For the control circuitry, Leo recovered what he could of his torn notebook diagrams, affixing damp pages between sheets of clear plastic, and reassembled the PCB from salvaged components. A marine-rated MOSFET bridge he'd scavenged from a defunct Bill J pump controller, a microcontroller board repurposed from an old autopilot system, and a set of surge protective varistors. Soldering under the lantern's glow, he reinforced every joint with corrosion-resistant alloy and applied a conformal coat to guard against salt spray. Finally, Leo reassembled the converter, sliding the rewound stator into the refurbished housing, bolting the turbine blade assembly atop a newly greased bearing, and wiring the control board into the capacitor bank buffer. He tethered the entire unit to a length of thick marine rope rigged overhead, giving him room to inspect the rotor's balance. A gentle pull spun the blades, which whirred smoothly without the previous wobble. Exhausted but exhilarated, Leo stepped back to admire his resurrection. What had been discarded as scrap was now a seaworthy rig, its components reconditioned and reinforced. As the lantern guttered and the workshop's shadows deepened, he felt the familiar thrill of creation. The discarded prototype had been reborn, ready for its true test on the rolling waves. At first light, Leo towed his newly rebuilt wave energy converter down to Crescent Cove, a wind-swept inlet known for its reliable swells. The rocky shoreline was slick with seaweed, and the morning mist curled around the concrete remnants of an old pier. Leo wore thick neoprene gloves and waterproof overalls as he carried the heavy unit, its aluminum housing gleaming faintly in the grey dawn, onto the pier's edge. He positioned the converter so that its turbine blades hung just above the waterline, the lower portion submerged in the incoming tide. Using a length of galvanized chain and marine-grade shackles, he anchored the base plate firmly to a steel mooring eyelet embedded in the pier. He then unspooled heavy-duty submersible power cable from a drum on the deck, feeding it through a watertight gland into the converter's control compartment. On the pier's surface, he stripped back the cable's outer sheath, terminating the conductors into a waterproof junction box fitted with marine-grade cable glands. Next, Leo and Jonah, the local fisherman who had agreed to host the test, carried the cable end into Jonah's rustic cabin, its walls patched with driftwood and barnacle-scarred planks. Inside, Leo located the cabin's main lighting fuse and tapped into the circuit using a waterproof terminal block. He rigged a simple control panel beside the main breaker, a digital power analyzer, an on-off switch, and a voltage display. A small LED lamp over the panel flickered as he energized the control circuits. Outside, the ocean swelled in rhythmic sets. Leo consulted his handheld anemometer, wind gusting to 10 knots, and measured the wave period at 3.2 seconds with his stopwatch. He toggled the converter's startup switch. At first, the turbine blades creaked against the shaft's inertia, but with each crest, the assembly gained speed. He watched the tachometer needle climb to 45 RPM, then settled into a steady 60 RPM as the larger swells engaged the airfoil curves precisely. On his panel, the voltage display jumped to 18 volts DC. Leo flipped the switch linking the converter output to the ultra-capacitor bank he had installed inside the converter housing. The capacitors drew current, their gauge rising from 0 toward 50 volts over the next 2 minutes. When the voltage reached 48 volts, his configured discharge threshold, an automatic relay closed, routing power through the submersible cable back into the cabin's LED lighting circuit. Inside, Jonah flicked on the new LED fixtures above his workbench. 4 bright panels, each consuming just 3 watts, lit the cabin with crisp white light. Jonah's face lit up as he plugged in his battery-powered radio. Its tuner glowed green, and the faint crackle of maritime weather broadcasts drifted through the speakers. "By the sea," Jonah exclaimed, voice echoing in the small room. "I haven't had light this bright since the hurricane." Leo monitored the power analyzer, steady 12 watts of output, with an energy efficiency of 68%, surpassing his target of 60%. He recorded the wave height at 1.5 meters and the generator's temperature at 40 degrees, well below the 50 degrees safety limit. Over the next hour, as the tide rose, the converter powered both lights and Jonah's radio continuously, even as swells varied in amplitude. Leo logged each data point, wave period, RPM, voltage, current, and temperature, onto a waterproof datasheet stamped with GPS coordinates and time-stamped by his handheld device. As the sun climbed, beams of light danced on the water's surface, and Leo and Jonah sat on the pier's edge, legs swinging above the surf. The cabin glowed behind them, powered solely by the relentless motion of the sea. Proof that Leo's resurrected prototype, once discarded, was ready to revolutionize renewable energy, one wave at a time. That afternoon, a chance encounter set Leo's wave energy converter on a viral trajectory. A maritime blogger named Sienna Tran, specializing in off-grid innovations, had been following Jonah's fishing expeditions and arrived at Crescent Cove just as Leo and Jonah were packing up after the successful field test. Sienna's camera, mounted on a stabilized gimbal, captured every meticulous step. Leo anchoring the converter to the pier, the turbine blades spinning in perfect cadence, the LED lights flaring to life inside the cabin, and Jonah's delighted reaction as he tuned his radio to the crackling weather broadcast. Her running commentary, delivered in crisp, enthusiastic tones, highlighted technical details, blade pitch angles, ultracapacitor voltage curves, power output readings that resonated with both DIY enthusiasts and clean tech professionals alike. Within hours of Sienna uploading the uncut field test video to her YouTube channel, the clip began to trend across multiple platforms. On Twitter, the hashtag #WavePowerDIY exploded as engineers, fishermen, and off-grid homesteaders retweeted Sienna's post, praising Leo's seamless integration of solar and wave inputs. Comments poured in: "Is that coral safe? Can we get plans for the blade molds?" And "This is what sustainable energy looks like." On Reddit's ER engineering porn, users dissected the design, pointing out the novel use of marine-grade stainless steel, shafts, and the custom-etched graphene electrodes in the ultracapacitors. Within 24 hours, the video had amassed 500,000 views and sparked discussions in clean energy forums from Scandinavia to Southeast Asia. Recognizing the groundswell of grassroots interest, Leo seized the momentum. He uploaded open-source schematics and step-by-step assembly guides to GitHub, complete with CAD files for 3D printing turbine hub prototypes and bill of materials lists for local fabrication. Each instruction sheet was annotated with safety warnings, proper sealing of the stator housing, torque specifications for mooring bolts, and marine insulation best practices, ensuring that even novices could replicate his design without undue risk. He also launched a simple website, wavediy.org, where users could submit performance data from their own builds, RPM logs, generated wattage, and local wave conditions. Within days, data from dozens of volunteer installations began populating his interactive global map, pinpoints lighting up as far afield as the Orkney Islands and the Maldives. Meanwhile, development NGOs and university labs took note. A coastal resilience nonprofit in the Philippines reached out to propose a pilot in a remote island barangay, where nightly blackouts hampered refrigeration and water pumping. An academic group at the University of British Columbia requested collaboration on optimizing the turbine's CFD profile for colder, denser waters. Leo's inbox overflowed with partnership inquiries, crowdfunders offering seed grants, marine engineers seeking joint patents on advanced blade materials, and humanitarian organizations eager to electrify refugee camps. Through this viral proof of concept, Leo's once discarded wave energy converter transcended its humble origins, catalyzing a global movement to harness the ocean's power, one DIY installation at a time. Within a month of the viral DIY movement, Leo Morales received an invitation that would change everything. The International Coastal Engineering Symposium in Bergen, Norway, was extending him a plenary slot to present his replicated test results and open-source designs. The symposium hall, a grand timber-ceilinged auditorium overlooking fjords, was filled with pioneers in marine renewables, government delegates, and representatives from the European Union's Horizon Research Program. Leo stepped onto the stage with his laptop and a single slide, a live feed of logged performance data from volunteer-built converters worldwide. He began with the Moitate pilot's metrics: sustained 12 wh day from wave capture, 8 wh day from integrated solar, 99% uptime, and cost of building the unit at under $350 USD in local materials. Then he showed user-submitted logs from the Orkney Islands, where converters achieved 25 day in stronger North Atlantic seas, and from the Maldives, where small atolls used the devices to power desalination pumps at 15 day. His live updated GitHub map displayed over 200 active installations, each color-coded by performance band. The audience sat riveted as Leo detailed his next plan: a multi-site trial funded through a $2 million grant from the EU's Maritime Innovation Fund. The proposal called for deploying 10 full-scale, industrialized prototypes in Norway's stormy Lofoten archipelago, Indonesia's tidal straits near Sulawesi, and Canada's Bay of Fundy, alongside detailed environmental impact studies and grid integration tests. He outlined rigorous validation protocols, real-time SCADA data feeds, standardized power quality metrics, voltage regulation within +2%, and long-term durability monitoring under seasonal extremes. Following his presentation, members of the Horizon Program's review panel approached the stage. Dr. Ingrid Larsen, lead scientific officer, grasped Leo's hand. "Your grassroots evidence is unparalleled," she said. "We're delighted to fund your trials and collaborate on refining the control algorithms for optimal load smoothing." Behind them, EU officials drafted grant paperwork on tablets, their screens showing budget line items for prototype fabrication, marine deployment vessels, and a team of field engineers. Within 2 weeks, Leo secured the formal award letter and returned home with a $2 million contract. Back in his uncle's sailboat workshop, he assembled a cross-disciplinary team: an oceanographer from the University of Bergen, a CFD specialist from Indonesia's Institute of Marine Technology, and a mechanical engineer cohort from Dalhousie University in Halifax. Together, they redesigned the converter's blade profile using high-fidelity hydrodynamic simulations, iterating on leading-edge curvature to maximize lift in both swell and chop conditions. The control circuitry was upgraded to a real-time PID loop running on an ARM-based microcontroller, enabling adaptive pitch control of the turbine blades during rapidly changing wave heights. By the next quarter, 3 industrial-grade prototypes, each with injection-molded glass fiber housings, precision-machined turbine hubs, and sealed marine-grade electronics enclosures, were ready for shipment. In Lofoten, Leo and his team boarded a research vessel at midnight, braving 2.5-meter swells to install the first unit on a floating platform anchored offshore. In Sulawesi, the unit was mounted on a reinforced jetty, calibrated for tidal flow velocities. In the Bay of Fundy, it hung beneath a refurbished lighthouse pier, its generator output integrated into the local microgrid via a custom bidirectional inverter. Throughout the trials, SCADA dashboards streamed real-time telemetry back to Leo's operations center in the workshop. He monitored blade RPM, generator torque, capacitive bank voltage, and grid synchronization events. Each site's data validated performance targets: average daily energy capture within 5% of model predictions, no unplanned downtime, and 0 detected marine habitat disruptions per the underwater acoustics monitors they'd deployed. By year's end, the Horizon-funded multi-site trials proved unambiguously successful, culminating in a comprehensive final report lauded by the EU's Renewable Energy Directorate. Leo's side hustle design had evolved into a rigorously tested, universally adaptable wave energy platform, thanks to the global grant that recognized the potential he had once salvaged from a Helios Tech dumpster. As the multi-site trials concluded with resounding success, the renewable energy industry could no longer ignore Leo Morales' breakthrough. 6 months after the Bergen Symposium, Helios Tech, the very company that had discarded his prototype, publicly announced a multi-million-dollar licensing agreement for Leo's wave energy converter design. Their press release praised the technology's scalability, cost-effectiveness, and minimal marine impact, crediting the rigorous EU trials for validating its commercial readiness. Within weeks, major offshore energy firms integrated Leo's modular converters into existing wind farm platforms. In the North Sea, Ørsted retrofitted 2 of its turbine monopiles with Leo's wave units, mounting them on the substructure's crossbeams. The shared power bus allowed the wind turbine's inverters to balance supply. When wind speeds fell below cut-in thresholds, the wave converters automatically supplemented grid output, smoothing power fluctuations. Data from the joint operation showed a 15% increase in annual capacity factor, reducing curtailment losses during lulls. Across the Atlantic, Canada's Crown Corporation installed a 20-unit sun-wave array off Nova Scotia's coast, jacking wave converters onto oil rig decommissioning platforms. The existing subsea infrastructure, power cables and maintenance corridors, enabled rapid deployment and connectivity to the provincial grid. Local utility records indicated the hybrid platform provided up to 5 MWh of clean energy during winter months, offsetting peak demand for heating and contributing to carbon reduction targets. In Asia, renewable energy giant Sino Energia opened a dedicated blue energy division, contracting with Leo's newly formed company, Waveco, to manufacture converters at scale. Their Suzhou facility churned out 5,000 units in the first production run, deploying them along China's eastern seaboard to power buoy farms monitoring water quality and coastal erosion. Waveco's partnership with Sino Energia included technology transfer agreements, ensuring local assembly under a Build China, Power China initiative. Even the offshore oil industry took notice. A consortium of Gulf operators signed memoranda of understanding to trial Leo's converters on idle platforms in the Gulf of Mexico. By harnessing wave energy, they aimed to power decommissioning operations without diesel generators, cutting costs and emissions. The consortium's pilot, conducted in coordination with the US, Department of Energy's National Renewable Energy Laboratory, confirmed that wave-driven power could sustain continuous operation of heavy lift cranes and remote sensing buoys. Meanwhile, venture capital funds poured capital into wave energy startups founded by Leo's former collaborators. Series A rounds in London, San Francisco, and Singapore financed R&D into composite blade materials resistant to biofouling and corrosion. Strategic acquisitions followed. Major marine engineering firms bought stakes in Waveco, giving Leo's technology access to global fabrication networks and deep water installation vessels. By the end of the year, the International Renewable Energy Agency's annual report declared wave energy the fastest-growing segment of the sector, with installed capacity doubling from 100 MWh to 200 MWh, thanks largely to the Morales effect. Industry. Conferences featured panels titled "From Dumpster to Market: Disruptive Innovation in Marine Renewables," with Leo often headlining keynote sessions. His once-discarded prototype had, through open collaboration and rigorous validation, become a cornerstone of the emerging blue economy, sea-based power generation that complemented wind and solar, offering resilience and round-the-clock output in the world's coastal regions. 2 years after the dumpster debacle, Leo Morales stood on the polished stage of the United Nations Blue Economy Summit in Lisbon. His wave energy converters now underpinning a global shift toward ocean-based renewables. Behind him, a panoramic LED display showed a world map lit with thousands of wave converter icons along every continent's coastline, each linked to grid and off-grid installations powering communities, research stations, and commercial platforms. He opened with a measured nod. Distinguished delegates, colleagues, and friends, today we recognize that the ocean's energy is no longer the toil of waves beneath empty, buoyed hopes, but the backbone of our sustainable future. He clicked to a slide, titled Global Deployment Metrics, revealing 1.5 gigawatts of installed wave capacity, 200 manufacturing plants across 30 nations, and 5 million coastal households now electrified without carbon emissions. Leo recounted the technology's journey, from a discarded prototype retrieved from a dumpster, through grassroots DIY adoption that spread via viral social media, to rigorous multi-site EU trials and commercial licensing by major offshore energy firms. He highlighted the industry's integration milestones: wave-wind hybrid platforms in the North Sea, oil rig microgrids in the Gulf of Mexico, and carbon-neutral desalination in island nations, a testament to the converter's adaptability. The next slide showcased the Global Wave Energy Cooperative, a UN-backed consortium Leo founded to ensure equitable access and community ownership. Its membership spanned small island states, coastal municipalities, and indigenous fishing communities. Under the cooperatives model, each deployment operated under local governance, revenue sharing agreements, and mandatory reinvestment in marine conservation programs, ensuring that wave energy empowered rather than exploited coastal ecosystems. He then presented the Lisbon Declaration on Blue Energy Equity, signed moments earlier by representatives from 75 countries. The declaration committed signatories to mandate a minimum 10% of renewable energy portfolios to wave and tidal technologies by 2030, provide technical and financial support for capacity building in least developed countries' coastal regions, establish regional blue innovation hubs to incubate next-generation marine energy solutions. As he spoke, delegates rose to sign on digital tablets, their signatures cascading across the screen. Leo concluded, "The blue economy is not a distant frontier. It is the wake of our collective ambition, a promise that our seas will fuel our civilization without costing our planet. Together, we ride the crest of this revolution." Thunderous applause filled the hall. Journalists swarmed Leo afterward, capturing his vision for wave energy as the third leg of a truly balanced clean energy stool. Backstage, Global South delegates thanked him for the cooperative's equity focus. Standing on Lisbon's waterfront later that evening, warm Atlantic breezes guiding cargo ships and sailboats alike, Leo looked out at the waves, knowing that the power he had once resurrected in a sailboat workshop now surged through the world's grids, lighting homes, schools, and hospitals, and that the blue economy he helped birth would keep rolling forward on every crest. Спросить ChatGPT.